Hi guys, so today I'd like us to talk about a Python concept that I don't think a lot of people talk about that much, and that is decorators in Python, right? And I want us to go into how decorators are actually created or the way they work, right? And to do that, we have to first understand how functions work because essentially decorators are just a form of function. You want to consider it like a higher form of function to just think about it. So just follow me through my thought process whilst we go through what a decorator is, right? So first, we have to understand what a function is, right? I mean, generally speaking, if you already know what programming is and you've been programming for some time now, at least in Python, you'd understand that, a function is basically a black box where you give it some input and it gives you an output. Essentially, when you think about it, it's just like functions in math, right? And these functions is this concept of functions is what we use to organize our code and make it more reusable. So for instance, I could create a function like this in Python for adding 2 to any number that we give it. So any integer that we give it, it should essentially just return another integer, right? And then what it will do is to basically return the number plus 2, right? So when you do this in Python, you have created a function that essentially adds 2 to any number that you give to it. So if I want to use this function, for instance, I would call this function like this, add 2, and pass in whatever number I want to give it. Like I'll give it maybe 90, and I'm expecting it to like return something for me. So I'll take result from here, assign it to whatever I'm getting from this function, and then I could go ahead and then print out result to see what I'm actually getting. So if I go ahead and run this code, you realize that I get the result being what, 92, telling me that okay, this function actually works, right? I could call this function anywhere I want, but then basically this is the concept of function, right? You have like some organization of code and a bit more reusable. So instead of me having to write at every single place whatever I want to add 2 to, like plus 2. I mean, plus 2 is something very simple that you would most likely not use a function for. But I know you guys already understand what a function is. I'm just trying to like set the grounds for what we are about to do today, right? Yeah, so I've gone ahead to modify our code a little bit to, write how complex functions can get, right? So in this case, we are writing a function which would get all the even numbers below wherever we pass it. So we have a function called get evens below, and then it takes an upper limit, which is an integer, and what we do is to basically iterate over that number that's given from 0 to that number. And if the number is an even number, if the current number that we are on is an even number, we append that to a list of even numbers that we are keeping, and at the end of the for loop we return those even numbers that we get. So you realize that when I go ahead and then run this code again, now we get a list of all the even numbers below 90, so from 0 to 468 up to 88, right? So yeah, we understand what a function is. Function is just a black box which takes in some digits and return us some result that we use. It might be like, you might be thinking about it to be more complex than this, but then on a very low level, that's the understanding I would like you guys to get over here, right? So now what I would like us to understand is that we can do more than just this. We can create a function in a function, for instance, right? So I'm going to try and replicate what we've done over here. So I'm just going to go ahead and copy this into a new file that I'm calling functions in function, right? We can create a function inside a function, right? So in here, I could define a function inside my previous function, and this function would be like, it's even, right? And this would take in a number, which is an integer, right? And then what it would do is to return a boolean of whether the number that it has taken is even or not. And essentially, what we would do is that this check that we are doing over here to check if the number is even or not, we could move this check in here, right? So then in here, when we are writing a for loop, we don't need to suffer. We could just say that if is even, then we pass in the number to it. If this is true, sorry, if this is true, then we could go ahead and then append this, right? And this shouldn't be an if statement. We could go ahead and then just return this. I think this makes sense, right? So this is a very basic function that we are defining inside the function. But what I'm trying to put across here is that we can indeed define a function inside a function. We can nest a function inside a function. So we are nesting this function is even inside this function, and the scope too would be limited to just this scope. So I can't call this function outside of this function. So over here, this should not work. I can't go ahead and say it's even here and passing 0 to it. Like you see, Pylint doesn't even know where the is even is coming from. So the scope of this function is only limited to it being used in here. So you can nest a function in a function. This is something that is very possible in Python, and it's sort of like a not so common thing, right? But then it's possible, and it has a lot of use cases. One of those is it being used in the creation of decorators, which we are going to get to in a moment. But bear with me, this should actually give us the same results that we got in the previous one. If I go ahead and run this code, you realize that we get the same result, even numbers from 0 to 46 through to 88, right? So it works. Now that we understand what a function is, and we also understand that functions can actually be nested in functions, I want us to understand one other important thing about Python. Now, Python is an object-oriented programming language, which I believe if you've been using programming if you've been programming in Python for a long time now, you would be able to quickly identify that Python is an object-oriented programming language. It's kind of like those things that we hear whenever we are about to start learning a new language, like this is object-oriented, this is not object-oriented, this is procedural. It's just what it is, right? But what this means is that everything in Python is an object. Even the functions are objects. So numbers, classes, objects of classes are objects. Numbers, floats, integer, whatever it is that you use in Python is an object. And that's the beauty of Python, right? And what this means for us is that we can pass a function as an argument to another function. We can pass a function as an argument to another function. Just to clarify, whenever you are defining a function, you have a variable over here that you use to represent whatever will be passed to the function, right? And for instance, we are calling this one an upper limit, right? But then the general form that we give, the general name that we give to this variable that we have over here is a parameter. So you have a parameter of upper limit which you are using inside of this function, right? But then from the outside world, this number that would be passed to it is called an argument, right? So you call the 90 an argument, and then in here it's being called as parameter. It's just a matter of semantics. You can choose whichever of them you want to use, but arguments and parameters. Yeah, I also get confused sometimes. But what I'm trying to say is that right now we are passing this 90 as our argument to this function, right? But then just as we are passing 90, we can also pass functions, like we can pass a whole function in here. Let me show you a practical use case. Let's say we want to create a function that will filter out all the odd numbers for us. So what we are going to do is this. I'm going to create a function which checks to see if something is odd or not, right? So define is odd. It takes in a number, which is an integer, and returns a boolean, true or false, depending on whether the number is odd or is even. It returns the opposite of the number being divisible by 2 without any remainder. So number modulo 2 equal 0. You know that this means that the number is an even number. So if you are returning the opposite of this, then the number is an odd number. So for instance, if I pass in a 2 over here, this will give me 2 is an even number, we know for sure. So we are expecting this function to return the opposite of that. So 2 over here will make this expression that we have written over here evaluate to true, and since we are not in that, we end up getting false, meaning that 2 is not an odd number, right? So we could go ahead and call this function is odd and call it on 2, right? Let me just put result here and print out what? Result. If I go ahead and run this, the result should give us a value of false because 2 is not an even number, right? Sorry, 2 is not an odd number. So if I was to run this with, say, 3, for instance, now we expect the value to be true, right? But we are still not done with what we wanted to do. We want to filter a set of numbers based on whether it's odd or even. So say raw, something like this, and let's say I want to filter this and just return only the odd numbers from this set. So what we're going to do right now is to define a new function which is called filter based on, and what it does is that it takes the raw thing that we want to filter, and it also takes a filter function, and basically it goes through everything inside the raw function, and if the filter function returns the value of true, then it adds that to a filtered list which is initially an empty list, and it keeps adding the correct ones to, and it essentially returns the value of filtered. So now let's go back to the concept of passing a function as an argument to a function. Now if I want to use this filter based on, I'm going to give it the raw, let me just say raw equals raw, and I'm also going to give it what? A filter function, and this filter function would be its odd function that we just defined, right? It's odd, right? That we just defined. So you can see here clearly that I defined a type of this filter function as a callable, which in Python, when you're given type hint, the callable is supposed to refer to a function. So yeah, basically I'm expecting a function that takes in an integer and returns a boolean, and our odd does that, right? So when I call this function and I return results, and I go ahead and print out results, it should give me all the odd numbers inside of this, just the odd numbers. So right here in my terminal, functions object, prints out this, I get only the odd numbers, 1, 3, 5, 7, 9, and 11. So the takeaway here is that a function can be passed as an argument to another function, because functions are objects, just because of the fact that basically everything inside of Python is an object, right? Object-oriented programming, right? Python is an object-oriented language, that kind of idea. Functions can be passed as an argument to another function. Now, based on our understanding of the 3 previous facts that we just looked at, we looked at what a function is, the fact that functions can be defined and nested in another function, and the fact that functions are an object and therefore can be passed as an argument to another function. Based on these 3 facts, say we want to find a way to time how long it takes for our functions to actually run. I want to create some sort of wrapper around whatever function I give, and then that wrapper would do the timing for me and make sure that I get the time. Let me code it out so that you get a sense of what I mean. I'm going to create a function called wrap in timer, and what this will do is to take in another function which I'm calling func, and inside here I'm going to create a nested function called timer, right? And basically what this does is to get the current time. So I could from date time import date time, and what this inner function would do is to get t1 as in time 1, and this will basically just be date time dot now, right? And then it would call the function func, right? After the func has finished running, it will record time 2 as well, which would also be date time dot now, right? Then it would find a time difference, delta equals what? Time 2 minus time 1, which would be our time difference, and we could maybe print out a message to the user saying that function runtime, and we could maybe use an f string here, and here we could be like delta dot seconds, right? It's a property, not a function. So yeah, delta dot seconds, and this should be it. And what we are going to do is to rather return the timer function in here. So which means that whatever function you get in here will get wrapped in timer, and the wrapped version of it will be returned. And whenever you try to call that function, you end up calling the timer, which will do the calculation for you. Let me show you something, right? So what I've done here is to create a function which is similar to the one we used in our first file, which basically gets all the even numbers below 90. The actual content of the function is not really the matter, but what I'm doing here is to pass this function to our wrap in timer function right here. So this get evens below 90 will come in here as function, then it will be wrapped inside this function, and then the wrapped version, which is the timer, would be returned to us as the resulting func. So if I go ahead and call the resulting func, you realize that all of this code will execute together with the function as well. We are not really doing anything with this resulting thing, so I could rather print out the evens instead. That would make us see what exactly is happening, right? So if I go ahead and run this code again, then we see that this code executes, but then again the function runtime is also given to us in seconds, right? I think it didn't take that long to execute, that's why we were given the value of 0. But then the concept is that we were able to wrap this around this function, whatever function it is that we take, we're able to wrap it around something and return the wrapped version of it. And basically this is how a decorator is supposed to work. Now finally we are on the word decorator. Essentially this wrap in timer function that we have over here is a decorator. It takes in a function and wraps another function around it, making sure that it sort of like extends the function of whatever function you have passed to it. Yeah, I know it's a bit complicated, but bear with me. Let's just go through it one more time, right? We have a function here called wrap in timer, which takes in a function as an argument, right? It takes in a function as an argument. So here, func is our parameter, right? Now, when we take in that function, because we are nesting a function inside of it, this func is actually accessible to us inside this nested function. So instead of us calling the function directly, we are taking our time to do our own logic and do our own thing, wrap that logic around the calling of our function that we are taking in here, do some printing out, right, before returning the wrapped version back to the user. So when the user wraps gets evens below 90 in timer, it returns another function which can be called. And when that function is called, you expect the wrapped version to rather be run. And since the wrapped version is actually wrapping the function that is being passed, the function that is being passed itself would also end up being run, right? But then basically this is like a general concept of decorators. But then you would ask me, Paul, this is not how decorators are used in Python. I've been seeing some @ sign somewhere. Don't worry, we'll get to that. But before then, let me show you one more thing. So say I want to create my decorator again. So now I'm going to call it a decorator. So I'm going to create a function called decorator. Is that spelled decorator? Yeah. I'm going to create a function called decorator. And what I'm going to do is to define another function in here and call it wrapper, right? And of course, the decorator is always supposed to take in a function because it doesn't make sense if it doesn't take in a function, right? Wrapper. And essentially what wrapper will do is to, print something. So let's say print before, then it calls the function, then it prints after, something like this. And what we are going to do is to return wrapper. We'll return wrapper instead of returning the function itself. So here we could create our actual function that we want to use the decorator on, say hello. And what this function will do is to essentially just print out hello. But because we want to use this decorator on this say hello, we can redefine say hello decorator, and inside of that we pass in the value say hello. So say hello would be sent to this decorator, right? Say hello would be sent to this decorator and it would be run over here, and then this would be returned as well. So now I can actually try and call the function say hello, right? This is how a decorator is supposed to be, a simpler version of what I wrote earlier. So now if I go ahead and run this, you realize that the before and after gets wrapped around the hello function. Now this same thing is what you would do if you were to write at Decorator here and remove all of this. Now you call say hello, and you realize that when you put this on top of your function, what happens is that Python would make sure to pass in your function as an argument to this decorator, and then now treat your function like anytime you call your function, Python will go ahead and pass your function to this decorator that you have placed here, and then call the return value of that decorator instead. So it's essentially acting like what we did. If I go ahead and run this code again, you realize that we get the same thing. You realize that we get the same thing before hello and then after. And this is how decorators come about. This is how you can create your own decorator. I mean, obviously, this is what I've written over here is a very simple explanation of what a decorator is. But then if you think about all the possible use cases of this, like using it to time, using it to extend the functionality of your functions. So instead of just saying hello, you want to do something before saying hello. Those kind of things. Say you want to create a decorator to log every time someone does something, right? So every time I do this, I could log or do something. You understand? So now that we are finally talking about decorators, we have to now think of how to actually sensibly use them, right? So I've gone back to the one that we created about timing how long a function runs, right? So we have our decorator here. We are calling our decorator time, and we record the initial time, run the function, record the other time, find the time delta, and print out how long it takes for our function to run, right? So it returns the wrapper. I mean, I think you already understand this. So now when I run this code, you realize that the hello gets printed and the time taken gets printed as what, 25 microseconds. Yeah, that works. This is exactly what we want. But now let's say we want to go back to what we did earlier. The function that adds 2 to a number and returns the result, right? So say add 2 and we take in a number which is an integer, and we are expected to return an integer again, right? So here we only go ahead and what, return number plus 2. This works very well. So if you could go ahead and what, call this, right? Expect this to be what, result, and we could go ahead and print out what, result. So now if you go ahead and run this again, then we have an error. It says that our add2 is missing one required positional argument, which is expected to be a number. Of course, that's my bad. I forgot to put something in here. Let's put 19 in here, go back and run our code again. Boom, an error. It says type error. It says time, the locals, whatever. But then saying that the wrapper takes 0 positional arguments, but 1 was given. This wrapper is actually referring to this wrapper over here. So which means that these positional arguments that we are passing over here will end up getting passed to it. Because in actual sense, this add2 will end up being the wrapper here. So one thing to take note of is that when you are defining this wrapper function or whatever it is, it must have the same signature as the function that you would be using the decorator on. It must have the same signature as the function that you'll be using the decorator on. Because when you are calling it here, you would be basically be calling the wrapper instead. I don't know if that makes sense, but then think about it. This 90 ends up getting added over here. So usually you could do something like args and what, and quags, right? Args and quags, and then you essentially pass them down to this, right? Something like this. It makes perfect sense, doesn't it? You run this again, it says what, time taken, blah blah blah, but then you realize that the return statements that you are supposed to get, what we are getting here in result, you know, let me just make this more sensible. So we could call this result like this, so that when we run this, we know exactly where the error is coming from. Run this one more time, boom, And I mean, it's working, not an error, but then there is a problem. The result that we are getting here is none. And why is that? Don't forget, when we call this function here, we are no more calling the function itself. It's sort of like we are calling the wrapper function. So we must make sure that, as I said earlier, the signature of this matches this thing over here, which means that this should also return, an integer, something like this. It should also return an integer. So we should have something like result here, set that as the return statement in here, and then make sure that we return the result as we are supposed to. I don't know if that makes sense, but then you are trying to wrap this wrapper around whatever you have created over here. You have to make sure you do it right, because at the end, this is what will end up being called by your user. When someone creates this wrapper somewhere, they would only give you this time or this name of the decorator, and then you would end up using the decorator over here. But to you want to make sure that, oh, when I'm using this, I'm just going to call an add2 and I'm going to return this. That's all you are thinking about. So you have to make sure you are doing two things. One is to make sure that any arguments that they are taking over here, you must make sure that you are also taking it. And you can have a generic way of doing this by just having these args and quarks over here and passing it down to the function. The second thing is to make sure that whatever is being returned from their function, you are also returning that back to the user, because at the end, you are giving the person the wrapper to use. So now, by returning this result in here, we should be able to actually see the 92 now with the time calculated. Let's run that one more time. 92 here, and it took us 4 microseconds for us to actually run the thing. I'm only printing out the microseconds. I don't know if it actually takes more than that. But it's not about the time taken. It's more about the way that everything here works out. Now, one more thing. Say we go back to our initial function that we are over here. Instead of printing out result, let's just say we print out get evens below, right? That's the name of our function anyway. If we were to print out this and run the code, here's what we get. It is an instance of a function, the function class. And this is the name of that particular instance. And this is the memory location that it's at. That's great. That's exactly what we want. That makes sense, right? Because everything in Python, like I said, is an object. So now let's try and do the same thing for our decorator. So here, we don't really care about this anymore. If I was to go ahead and print out add2 just as a function to get a similar thing, we might get something slightly different. So it says that it is a function, all right? It's an instance of the class function. But the name that is giving me over here is time, like the time function, and the local scope of that, there is a wrapper function over there. But wait, we called our function add2. Add2, why are you giving me wrapper? You want the add2 to have its own identity, innit? You want it to have its own identity. So of course, this doesn't make any sense. It's now seeing my function as the wrapper, because essentially that is what is being returned by our decorator. And that's a problem. Our function has lost its identity. Simple and short. It has lost its way. But yeah, to deal with this issue, Python has given us a way. Python actually comes with a module called functools, which basically has a lot of tools available for you to use when you are dealing with functions, right? And this functools module comes with you guessed it. It comes with a decorator called wraps. Can you imagine? It has a decorator called wraps. And here, what you do is to use that decorator on your wrapper, so wraps, use that decorator on your wrapper and give it the function that would be coming in. This would make sure that this underlying wrapper function that you are creating will have the same signature as the function that you are passing in here. Let's try that and see what happens. Would you look at that? We have a function, and now the name is actually recognized as add2. That's exactly what we wanted, right? I mean, this in itself is a decorator that is coming from Python, right? The inbuilt modules that come with Python, right? But then this decorator is supposed to extend whatever function that you are using it on, and it's just supposed to make sure that it gives this function the same signature as whatever function you're passing to it. So now we are giving the same signature of this function that's coming into our time decorator. We are giving that signature to our wrapper, which will be returned whenever we are using this add to. Just take a minute to breathe it in, right? Just look at it. This is beautiful code. So yes, with this, I think we have created a sensible decorator. I mean, it looks basic, but it's not basic. It's not that advanced as well. You could do a lot of stuff with this. This decorator that we have created is just for timing, how long it takes for a function to run and returns the result in milliseconds. It's not anything extra, right? But then we have taken this opportunity to understand exactly how decorators work and how we can actually create decorators ourselves. It's very rare that you would see people creating decorators on their own. They usually go ahead and write a function and call that function or something. You would usually not create a decorator, but there are situations that you'd actually want to use a decorator. Right now, I could publish this decorator to PyPy, right? P-Y-P-I, yeah? The PyPy or PyPy, however it's called. I could publish this decorator there, and anyone who wants to time his or her function will just use that decorator on top of their function, and that would be done. But yeah, guys, I know this is quite a long video, but I think I have gone over most of the basics of decorators. So at least you can now create decorators on your own and use them for whatever you want to use. Essentially, it is a function for extending the functionality of a function that you already have. But yeah, this is what a decorator is. It looks kind of complex when you look at it at first because it combines the three concepts of Python that we learned: functions, the fact that functions can be nested, the fact that a function can be passed as an argument to another function. It combines the three of that into one thing and creates a decorator. But a decorator is essentially a way of wrapping a function around another function to extend its abilities, right? I don't want to bore you with a lot of technical ways of doing things like this. I mean, I've already bored you with how long this video is. If you have watched this video up to this point, you have actually tried. Subscribe to the channel. I know you like my content. So what I would just tell you is that go ahead and go to the real Python website. I mean, you could just search for it. Search for primer on Python Decorators and learn something, like understand the concepts that are here. I actually had to read this myself to be able to explain this to you from my point of view, my understanding. But it tells you what a first class object is. Basically, that's what a function is, a first class object. You could go ahead and look at that and try and understand it. It tells you about the fact that functions can be defined inside another function, and tell you all about this. I mean, just go ahead and read this content and you'll be able to, it's free content online. You'll be able to understand more on how decorators come about and how you can go ahead and then create your own decorator. I know this video is very long, and if you actually made it out to the end of this video, you're actually one of my loyal subscribers, and I love you for that. But then, thank you guys for watching this video. If you did enjoy the video, you know what to do. Subscribe to the channel if you're new around here, and like the video if you actually like the video. It helps YouTube help me reach a wider audience. I want to send my content to a lot of people out there, and I need your help to do it. So yeah, guys, that's it for this video. I thank you guys for watching. Happy coding. Cheers.